All right. All right. All right, ladies and gentlemen. So here's the plan for today. We'll take our quiz near the end of the hour, ladies and gentlemen. Okay? We're going to finish the metal reactivity lab. We're going to take a look at those charges of ions that we did 2 days ago at the end of the hour where we put them onto our periodic table. We'll give you a chance to copy that information onto your periodic table again if you didn't. And then we will get into writing and naming compounds. That is our plan for today. Your test is going to be next week, Thursday. Okay? So next week, Thursday, you're going to have a test. It's going to be for Unit 3. Then we have one more unit to go, and we will have 3 weeks to get it done, including the final exam within those 3 weeks, ladies and gentlemen. So it's kind of a mad dash to the finish now. So today, after we're done talking about the lab, we're going to talk about valence electrons and how they affect bonding and reactivity. So that is what we started doing a couple days ago. We will finish that today. If you weren't here yesterday, I did put in the alternate assignment into the computer for you. So when you look at that alternate assignment, there are a bunch of pictures at the top that you could take and make observations of. And then there's a table that has all the information in it, and we will go through that. Now, again, ladies and gentlemen, before you turn this lab in, you need to make sure that you are doing the things that you can do to get as many points as you can. So I would like to go back up to the start of this real quick, just to remind you of a few things. Okay? So, in here, 3 of these 4 boxes need to be filled in for all 4 of these solutions. 3 of these 4 boxes need to be filled in for all of the metals. Again, you're describing what you see, what you felt, what you smelled. Those of you who weren't here, you're going to have to do the best you can to describe 3 things about the pictures you're seeing. But if you don't have at least 3 things for one of these, you're losing the point for it. So you're losing the point for it. So you might as well do them, ladies and gentlemen. Yes. Okay, thank you. All right. So again, this is the easy part of the lab, ladies and gentlemen. This is the part you don't want to mess up on. Okay? This table, ladies and gentlemen, this table should be complete. So what you should have is you should have things filled into these yellow boxes, either NR for no reaction or what you saw happen. Turned yellow, turned blue, got fuzzy, whatever. And then, ladies and gentlemen, you should add them up over here. How many reactions happened across the top? In one of these boxes, you should get 1. In one, you should get 2. In one, you should get 3 reactions. And those of you who got the alternate assignment, I have this table filled in for you, everything except this part right here. Okay? All right. That was what you collected in the lab. You've got the questions here, ladies and gentlemen. We went through 1. list the metals from the most reactive, the one that had 3 reactions, down to the one that had none. Silver was the one that had none. Refer to the activity series on the last page and explain why the Statue of Liberty was made out of copper instead of zinc. Here's the last page, ladies and gentlemen. The things at the top of this list are more reactive than the things at the bottom. So here's copper at the bottom, here's zinc at the top. Why do you think they made a statue out of copper instead of zinc, ladies and gentlemen? Question number 2, there is a material that you used in the lab that might have been a better choice than copper for the statue. If we use copper because of where it is, its reactivity compared to zinc, what would have even been a better choice there? Question number 4, why was this material not chosen? We did all of that yesterday. We were on this question, ladies and gentlemen. Given your knowledge, Damien, sir. Thank you. Turn that down because I can hear it over here. Thank you, sir. Okay. Given your knowledge of chemical reactivity among these 4 metals, which metal is most likely to be found in an uncombined or free state in nature? Okay. So let me explain what that means. When we find things in nature, ladies and gentlemen, we either find them alone or we find them in compounds. Those are the 2 ways that we will find them. Now, things that are very reactive are going to be found in a compound. Why? Because by being very reactive, that means they are going to try to find something to react with. And in nature, there are a lot of things that you can react with. So we very rarely find elements that are very reactive alone. They are normally combined with something else. So for example, sodium on the periodic table is element number 11. It is a very reactive metal. You will very rarely, if ever, find a chunk of sodium metal alone. You will find sodium chloride. You will find sodium hydroxide. You will find sodium fluoride. Sodium combined with some other element. Why? It's so reactive, if it gets the chance to combine with something else, it will. Okay? So, this question is asking you, what are you most likely to find alone? One element that you're likely to find alone, ladies and gentlemen, is gold. Gold does not react with a lot of things, which is why for years people moved to San Francisco, people moved west to look for gold. Why? Because you would find big chunks of it. You would find pieces of it, and it wouldn't be with something else. Why? Because gold is not really reactive. So when you're not really reactive, there is a much better chance that you will be found alone, not combined with something. Okay? Questions? I got to go back and see if there's one. So, think about that for a second, ladies and gentlemen. I'll be back. Okay. So, question number 5 and question number 6 are exact opposites of each other. So based on what we just talked about, based on what you found in the lab, which of the 4 elements is most likely to be found uncombined in nature, alone? So, magnesium, zinc, copper, silver. Which one of those 4, and don't tell me, type it into your box, is most likely to be found alone or uncombined? And why? What did we just talk about? What did we tell you about things that are Very reactive. What did we tell you about things that are not very reactive? So this is asking you which one you're most likely to find alone, not combined with something. Question 6, ladies and gentlemen, is the exact opposite. Which of those four metals is least likely to be found alone or uncombined? Or another way of saying it is which one is the most likely to be found in a compound? And the reasoning for 5 and the reasoning for 6 should be the exact opposite of each other. You have everything you need to now complete this lab activity, ladies and gentlemen. We are going to give you until 10 minutes till to answer those last two questions, to finish this up, and to turn it in. If you're good and you're done and you're fine, you've got a few minutes to take and look over the notes and add anything to your yellow periodic table before we take our quiz in a little bit. So, ladies and gentlemen, you've got until 7:50. That gives you about 8 minutes. If you have questions of me, call me over. I will be happy to come over and to assist you. If you're all finished with it, yes, but make sure every yellow box has something in it. Because if not, you're losing points. Nope. All right, ladies and gentlemen, please make sure you get this lab turned in by the end of the day today. Otherwise, it will be late and you will lose the chance of the bonus points of either an A or a B on the lab. What I'd like you to do right now, ladies and gentlemen, is take out that yellow periodic table that most of you have out. You are going to need it for today's quiz. We started putting some things on there last week on Thursday. We're going to continue with that right now, ladies and gentlemen. So make sure you have that out. I have the red and blue pens up here still if you want to come up and grab those red and blue pens. That is 100% up to you, ladies and gentlemen. But we need to make sure that you have certain notes on this periodic table. Now, if you lost it, there are new ones over there in the black trays over by the computer where you sign out to go to the bathroom. All right. So, we said the other day that depending on what family you were in, ladies and gentlemen, you can determine the charge on something. And even going a step back from there, we put this bold black line on the periodic table, or this bold line on the periodic table, to separate metals from nonmetals. And the reason we did that is metals and nonmetals do the exact opposite things in a compound, ladies and gentlemen. Metals will lose electrons. When you lose electrons, you become a positive ion. Another term for that is a cation. Nonmetals will gain electrons. When you gain electrons, you become a negative ion, and you are what is called an anion. We went even further then, and we broke it down, and we said that, all right, all of the metals in group number 1, ladies and gentlemen, are a +1 ion. They all do exactly the same thing. They all have one valence electron. They all lose that one valence electron. They all become a +1 ion. Now, I didn't do this the other day. We're going to do this right now. I'm going to make a special note about hydrogen, ladies and gentlemen. Okay? Now, even though hydrogen is over here at the top of group 1, hydrogen is a nonmetal, which means it can be a negative ion. Okay? So hydrogen can act like a nonmetal and be a -1 ion. Okay? But here's the thing about hydrogen. It can also act like a metal.
Can you zoom in a little bit?
I will once I'm finished writing.
Thank you.
Which means it can also be a +1 ion. So hydrogen is a very unique element on the periodic table, ladies and gentlemen. Hydrogen is technically a nonmetal. It will be a -1 ion, just like fluorine, chlorine, bromine, iodine, and astatine. But it also can act like a metal and be a +1, like lithium, sodium, potassium, rubidium, cesium, and francium. So it gets a little bit confusing with hydrogen. Okay? Questions? I'll let you finish copying that.
Wait, isn't that a metal, basically reactive metal?
It says it is a nonmetal, meaning it can act like a -1. But there are times when it can act like a metal and be a +1. So it can kind of do either one.
So you can like lose it or gain it.
Correct. It can lose an electron or it can gain an electron.
Alright. If it can lose it and gain at the same time, wouldn't it?
Not at the same time.
Oh.
It can either lose one or it can gain one.
So like when you got like 4 of them, you could like either lose
Well, first of all, how many does hydrogen have?
like, one extra, I think?
It only has one.
Yeah, one.
It has one electron. Now, how many Yes, Fantasia. Please, go ahead. How many electrons fill the outer energy level normally? What's the magic number? 8. 8. Remember group 14 here? Plus 4 and minus 4? Why? Well, it's no easier to lose 4 than it is to gain 4, correct? But in the first level only, how many electrons are there in the first level? No, there are 2. So guess what? Hydrogen has 1. That's half filled. So is it easier to gain 1 or lose 1? It's about the same. So hydrogen, if it is around a nonmetal, it can lose an electron to that nonmetal. If hydrogen is around a metal, it can gain an electron from that metal. It can do both. It's the one element that is a little bit strange that way. All right, ladies and gentlemen. Oops. So, let me zoom out a little bit. Okay. Now, the elements on the periodic table that are in this section right here, these elements, we didn't put any charges above or below them. And the reason we didn't put any charges above or below them is because it's not that easy to just predict their charge by where they're at. Many of these elements can have more than one charge. Iron, for example, can act like a +2 ion or it can act like a +3 ion. Cobalt can act like a +1 or a +2. Magnesium is only ever a +2. That is it. That is the only thing it can do. Potassium is only ever a +1. But these in here can do some weird things. Okay? There are a couple special ones, though, that are fairly normal. One of them is element 30, zinc here. I want you to, next to the symbol in zinc, put a +2. Zinc is always a +2 ion. Always. Never anything else. Okay? And silver, the element just kitty corner down below and to the left, is always a +1. Okay? Always a +1. So, these two, we know their charges. The rest of these, we don't. Okay? Now, for every rule in chemistry, there is always an exception. Those are the exceptions in this area. Those are the ones that only have one charge. But now, ladies and gentlemen, we are going to talk about tin and we are going to talk about lead for a second. What is the charge on tin according to where it's at on the periodic table? Can I ask where you're getting 6 from?
From the side, like when it goes down from 1 to...
Okay, but it's group 5.
Yeah.
Or period 5.
All right.
Where did we put charges, Solomon? Where did we write them on the periodic table? Somebody tell me.
Oh, right on top. Yeah, right on top.
What's the charge on top?
You got a 4.
What kind of 4? Positive or negative?
Negative 4.
No.
You can lose -4 or you can gain 4.
These are below the bold zigzag line, right?
Oh, okay. You got
So they go down to the bottom to be a +4. These two that are above the bold zigzag line go up to the top to be a -4. Okay? Okay. But tin is an exception. Tin can be a +4, ladies and gentlemen. Absolutely no doubt. But it could also be a +2. That is a weird thing about tin. It can be a +4 or it can be a +2. So can lead right below it be either a +4 or a +2. So those are the special exceptions that you need to write in those areas, ladies and gentlemen. Now, if I give you a compound with tin or lead, I have to tell you if it is a +2 or a +4. I have to tell you. I don't expect you to be able to know. Okay? Someone has to tell you, and there is a way we can tell you in a name what charge it has. We will get to that. We will get to that. Okay? But now, ladies and gentlemen, what this means is, Adon, the charge of sulfur be in a compound?
-2.
Correct. You go up to the top because it's a nonmetal. That's how you find its charge. Jose, what will be the charge of carbon?
-4.
-4. What will be the charge of gallium, Fantasia? +3. Heavenly, what would be the charge of calcium? What's that? +2. Thank you. Go down to the bottom to find its charge. Natalia, what would be the charge of lithium? +1. All right. Karina, what would be the charge of krypton? Up to the top. What? 0. Yes. It would be 0 or none. Thank you. Either one. You could say either one. Okay. Kenya, what would be the charge of chlorine? -1. What would be the charge of selenium, Nico? Well, everybody else is going up to the top and seeing what the number is at the top. Well, be more specific. Thank you. -2. Charges are either positive or negative, and then a number. -2. So for selenium, we go up to the top. There's its charge. Okay? Alexander, silicon, what's its charge? -4. But germanium, what is its charge, Damien? +4. We go down to the bottom. Okay? We go down to the bottom. Jesus, what's the charge of strontium? +2. Kenya, what is the charge of cesium? +1. Questions? Easy enough to find the charge, correct? Questions on that? If you can't do that, you're going to struggle with what we do next. So questions. All right. So now, ladies and gentlemen, please open up your notes for the class. Okay? Open up your EISN and go to slide number 25 real quick. Now, you have already copied this slide down into your notes. You should have. Okay? This was that table, and this is how we got those numbers that you were just telling me. So the metals in group 1 are all a +1. The metals in group 2 are all a +2. The metals in group 3, in group 13, my bad, I was looking at the valency electrons, not the group number, 13 are a +3. Group 14, plus and -4. -4 at the top, +4 at the bottom. Group 15, -3, 16, -2, 17, -1. In group 18, as Karina told us, no charge. Noble gases are unreactive, meaning they do not combine with anything. By the way, these were the last elements to ever be discovered. Any idea why? What? Nope. They're natural. But they were the last elements to be discovered. Okay, you're semi-right. Not about the low quantity, but the fact that, number one, they're gases. It is hard to see gases. Number two, they are unreactive. Many things were found not because we found them alone, but because we found them with something and we were able to separate them. Okay? So you're trying to find something that doesn't react with anything. You're trying to find something that is a gas. You're trying to find something that is very hard to find in that way. So they were some of the last elements found, ladies and gentlemen. Some of the last elements discovered. Okay? And that is why. Now, for this class, ladies and gentlemen, on Monday we are going to start writing and naming some compounds. Now, there are two basic types of compounds that we have in chemistry. One is called an ionic compound and one is called the covalent. Is this in your notes already for you? On slide number 26.
Yeah.
It's all filled out? Okay, good. Then I can just talk about it and I don't have to have you copy this. Okay? An ionic compound is between metals and nonmetals. Metals that want to lose electrons, nonmetals that want to gain them. Perfect match, ladies and gentlemen. An ionic compound is between two or more different elements. Karina.
Is this going to be on the quiz
No. The quiz ends with what we did a couple days ago where we talked about finding the number of protons in carbon, the number of neutrons, things like that. No, wouldn't do that to you, wouldn't give you that to you on the quiz. No. Atoms transfer electrons. When they do, they get opposite charges. What do opposite charges do to each other, ladies and gentlemen? They come together. So remember, atoms combine to become stable. They become stable by filling their valence shell. So this atom loses electrons to another atom that gains them. As soon as I lose electrons, I am now positively charged. The problem is the other atom that gained them is now negatively charged. And those opposite charges attract each other. And those two atoms are stuck with each other. Not because they want to be stuck with each other, but because they wanted to become stable, and by doing so, they got oppositely charged, and now they're stuck with each other. Okay? So, opposite charges attract each other. Compounds are stronger. That should say these compounds are stronger than covalent compounds. Ionic compounds are stronger than covalent. Okay? Covalent compounds are between two or more nonmetals. That's it. Just two or more nonmetals.
I got a question.
Shoot.
If all of them are trying to become like, I don't know, stable, wouldn't it just like everything's gonna become stable, or is it like break off by like?
Well, everything tries to become stable.
Yeah, but some things become stable, right? Just like
Correct.
helium. Yeah, helium. So wouldn't like everything become stable after some time or something?
And that's why things go into compounds. That's why we find things in compounds. Because when they're in compounds, they become stable. That's why we will very rarely find cesium alone. Cesium is a very reactive metal. Excuse me. Very reactive metal. So reactive that you'll hardly ever find it alone in nature. It's going to be combined with something. Why? Because if it goes around anything that will take electrons from it, it does it. But then it makes a compound, and it's stuck with that. So now we have a compound that has cesium in it. Okay? Gold still wants, if it does anything, it wants to lose electrons. But it's not very reactive. So even if gold comes around oxygen or nitrogen or chlorine or fluorine or bromine or one of the other nonmetals, it's like, okay, well, I really don't want to lose my electrons anyway because I'm not very reactive. Okay? We learned that in the lab yesterday. There are some metals that if you give them a chance, they will react. We saw that with magnesium, right? Some metals don't react. We saw that with copper. We saw that with silver. Those two metals didn't react much at all. Those two metals are like, nah, I'm fine. I'll just, I would like to get rid of this electron, but I'm okay. All right? So, it's kind of like people in a way. Some people are happy without other people around them. Some people need other people around them. Okay? So, covalent compound atoms share electrons. Now, an important thing about a covalent compound, if you share electrons, you never get a charge. So there's no positive and negatives attracting each other. It's just two different atoms that have a common goal of sharing something. Have you ever gone to the movies with someone, ladies and gentlemen?
Yes.
If you go to the movies, you've got to get what when you go to the movies?
Popcorn.
Popcorn, right? Now, I noticed the movies have a deal where you can get a small popcorn and a soda, right? And you can each get one of those. Yeah, I don't do that when I go to the movies with my wife. We get like the jumbo popcorn, right? So the jumbo popcorn, we share it, correct? But for us to be able to share it, we have to sit where?
Together.
We have to sit together. Because we're sharing this, we have to be together in the same area, right? Same thing is true with a covalent compound. Atoms are going to share their electrons between the two atoms. But to do that, they have to stay together. It's not sharing if my wife goes and sits down and I grab the popcorn and go sit somewhere else in the theater, right? Okay, it may be good for me with the popcorn, but she's not sharing anymore. So the only way you could share is to be together. That's a covalent compound. Okay? But guess what? Once the popcorn's gone, is there any reason for us to sit together anymore? No. So you could easily break us apart. Okay? If we walked into the theater and it was packed, we're not sharing popcorn. Because if there aren't two seats next to each other, one of us is getting the popcorn and one of us ain't. Okay? So covalent compounds can be broken apart easier than ionic can. Why? Because when you're gaining and losing electrons, you're attracted to one another. When you're sharing, it's like you're there just for the popcorn. Popcorn goes away, well, I guess I could break apart if I wanted to. Okay? Questions? All right. So, this is where we're going to stop today. On Monday, we will start making and building compounds. And we are going to begin with these. Now, again, next week we only have 4 days. There's no school next Friday for you guys. Okay? So next Friday, you guys are off of school. So Monday and Tuesday, we'll talk about compounds. Wednesday, we'll do some reviewing. Thursday, we will take the test. You'll have a nice 3-day weekend with very little to worry about unless you're missing something for my class. And then when we come back, ladies and gentlemen, it is a 3-week rush till the end of the trimester.
3-day weekend next week?
Yes. You're off on Friday. I don't know why you keep looking at me like that. You're off on Friday. Trust me.
Wouldn't that be 4 days then?
Friday, Saturday, Sunday. You'd have 4 days of school next week and you're off on Friday.
I thought you were saying you're going to have like 3 days of school.
No, you're going to have 4 days of school. You're going to be off next week, Friday. Okay. All right, ladies and gentlemen. Take out your periodic table. Take out your computer, ladies and gentlemen. The 4 of you that are sitting together back there, 2 of you come and sit over here, please.
I'll go.
Damien, you could stay there. Just slide your desk over a little bit toward Alexander. Okay. Thank you, sir. Now, on the quiz,
Yes, all right. I go.
there are questions that are going to ask you to tell me 2 things about protons, neutrons, and electrons. You just need to tell me 2 of the 3 things about their charge, their location, and their mass. Okay? So, when you get to those questions and you're typing in your answer, they don't have to be in complete sentences. They just need to be a complete answer. Okay? Just need to be a complete answer. All right. I just published the quiz for you, ladies and gentlemen. So if you go into the class, Canvas class, you will find the quiz at the bottom of the Unit 3 module. So, the class, modules, Unit 3 quiz is right there. So, go ahead and begin working on that, ladies and gentlemen. If you have questions, please raise your hand, call me over. I will be happy to come and help you.
Can I get a target?
I will see if there's ones back there. But here's the thing, ladies and gentlemen. You're my first hour class. I do not understand why I need to keep going and getting chargers for my first hour class when your computer should be as charged as it is going to be for the day. There are 2 freshman classes next door that are not taking any charging blocks out of there because they can manage to bring their computers charged. I would think that a bunch of juniors and seniors could. Now, if you need one, I will go get you one. Solomon, you need one? Heavenly, did you need one or do you have a question? It might have just finished updating. Yes.
Can I get that bathroom?
Go for it. You're wasting your quiz time. Leave your phone on my desk. Go ahead. go, sir. If you have any questions, ladies and gentlemen, call me over.